convert as a small SME enterprises and accelerate as a leader of big enterprise. The presence of Digital Fab Lab, the presence of Electroplant Park Bhubaneswar, the presence of EMC combinedly, I can see there is a greater significance for the and opportunity for the startup and ESDM industry in the state of Odisha. As an added initiative and to promote the successful in the ESDM startups, the state is offering a preferential allotment and in the EMC and access to the Common Central Facility Center CFC, which is comprising of various R&D facility, PCB prototyping, PCB assembly, test and measurement equipment facility, reliability lab. So once they graduate from the EP, they can get access to the EMC in terms of availing this facility, and subsequently for mass production, there is a preparation allotment for allotting land in terms of they can create their own manufacturing facility within the EMC. So finally, the essence, these plan initiative and the kind of capacity building program being undertaken by STPI and combinedly with Government of Odisha to boost the building the right ESDM ecosystem, innovation, and facilitate a larger proportion of the value addition across the electronics design value chain take place in the state in coming days. Once again, I'd like to congratulate IESA for successfully organizing the Vision Summit 2021 and extend my sincere thanks for inviting me to address this session. And at last, I'd like to mention to all the august audience present here that the second OCP challenge competition is on. You can go through the EP Bhubaneswar website and you can also apply if you have any innovative idea, innovative solution. With this, I'd like to thank once again to the organizer. Thank you very much.
Thank you, Mr. Panda, for enlightening the audience about EP Bhubaneswar and the policies of government of Odisha. Is he joining for Q&A? Okay.
Thank you. Thank you.
Yeah, Mr. Panda, thanks for joining us for the live Q&A. Just give me one moment, to pick some of the questions from the audience here. Just 1 second, please. Mr. Panda, while we are picking up the audience questions coming to you, just wanted to understand, of course, the ISA collaboration has been great with EP Bhubaneswar all these years. And just wanted to know how is the connectivity now from Bhubaneswar and rest of the areas in Odisha where the industry is coming up, ESDM industry. This is usually one of the concerns we hear from the global investors.
I'd like to highlight here, as far as connectivity is concerned, now that I don't think there is any problem connecting in terms of even to say the air connectivity to Bhubaneswar to other major metros. We have got maximum flights to all metros. Also, we have started connection because it is not Odisha is well, I think, rich in the mineral and metal sector. Lot of industries are there already. Lot of steel industries. They have, you talk about any major steel industry, manufacturing industry, they are here. Either they are here or they are in process. So all the corporate houses are there. Business environment is there. A lot of IT companies are also there. All big major companies, and we have got export from the state of Odisha almost 5,000 crore in last financial year. So, and tourism is also picking up like anything. Recently we announced connectivity to Goa, Jaipur, all the tourism destination. So we have got multiple flights to all metros, maybe 8 to 10 to Delhi, Bombay, Bangalore. So Bangalore is well connected, 3-4 connectivity, Hyderabad, Chennai, and all. So I don't think there is any problem. So because there is a
Okay.
demand, huge demand, and there is huge traffic, so we are well connected.
Thank you for giving that information. Another question that typically we hear from ESDM industry is about, availability of talent, especially when they go beyond metros. So would you also like to talk a little bit about availability of talent for ESDM industry?
I can talk about in overall talent pool availability. See, Odisha, particularly in Bhubaneswar, it is known as a education hub, and it supply talent to entire for the eastern part of this country, right? So you name all the Institute of Eminence or all the uh, technical institutes, their presence here in Bhubaneswar and in the state of Odisha, that itself gives a positive message to the industries. So we have got IIT in Bhubaneswar, we have got a triple IT in Bhubaneswar, we have got Institute of Mathematics, Institute of Material and Mineral Science, Institute of Life Science. So all repute NIT, IIM, so then Birla Institute, all these institutions are there. So the education system is very good, and, and apart from that, the deemed universities like Kalinga Institute of Technology, KIT Deemed University, they have done excellent job. So in the particularly in the, I think some of our ISA friends, they are also well aware. They are already in touch with the local institutional mechanism here. So there is good number of talent pool available in terms of freshers, uh, and those particularly in the electronics field. Electronics field, we have got very good engineering colleges. So I don't see there is
Thank you.
any problem. And a lot of
Okay.
people are well established outside Bhubaneswar. So there could be every possibility they want to come back or something. They want to help the entrepreneur. They want to come back as a entrepreneur or else in job if they get a good opportunity.
Thank you, Mr. Panda. I have another couple of questions from audience here for you. One is that there is a electronic manufacturing EMC cluster coming up in Bhubaneswar. Question is, how soon will this become operational for companies to start from there?
EMC was approved under the EMC one scheme of MIT. So the physical infrastructure is a greenfield EMC. So the physical infrastructure is ready. In fact, last to last week, I happens to visit. I got an opportunity to visit the TMC. So we've got 200 plus acre of land. It's clean land, developed land, and there are all like common facility centers, R&D centers, common facilities. Though we are in the process of procurement of the hardware equipment, common equipment in the common infrastructure facility, but the physical infrastructure, the platted complex, the physical in the R&D house, the employee center, employee residential center, there is the in-house residential facility for the employee working within the EMC companies. So those physical infrastructure already completed. It is a greenfield EMC again. I'm saying comprising of 210-acre land. Only thing is we are quickly in the process of procuring the hardware for the common facility center, which will be help.
Okay.
And one thing I briefed in my speech also. So while uh, con- considering the approval process in the EP Bhubaneswar, we have taken into consideration the entire chain, uh, like the startup who want to operate and go for a mass production kind of thing, they will be given preferential access in the common facilities center and the platted complex. Further, for a major manufacturing, they will be given a preferential accessment to access in the EMC to get the land so that they can go for a mass production. So that entire system is already in place.
Thank you, Mr. Panda. I have a couple of more questions, but in interest of time, we will send you an email and get this answered offline. So I'm sorry, but I'll have to let you go now. But I really thank you for your keynote, your presentation, and your taking live Q&A here with our audience. Thanks a lot, sir. We will move on to the next stage of our.
Thank you.
Yeah,
Thank you very much.
thank you, sir. Yeah. So, ladies and gentlemen, we have a next section of our presentation, and this is this presentation is from Mr. Pradeep Gupta, who is the head of Electropreneur Park in New Delhi. That is again a joint initiative of ISA. Before putting his presentation up, I just wanted to give a brief introduction of Mr. Pradeep Gupta. Mr. Pradeep Gupta is chairman of Cyber Media Group, which is a very well known specialty media house with brands like DataQuest, PC Quest, Vice and Data, CIOL, magazines, etc. Mr. Pradeep was conferred the National Entrepreneurship Award as the best mentor by Ministry of Skill Development and Entrepreneurship, Government of India. He's also chief mentor of Electropreneur Park, Delhi and Bhubaneswar. Pradeep is an angel investor and has mentored over 250 startups. He's co-founder of Indian Angel Network, Asia's largest angel network. Pradeep is also global trustee of TIE, which is world's largest entrepreneurial ecosystem. Pradeep also chairs the IIT Alumni Trust. Pradeep was the GP of India's first angel fund, Infinity Ventures. Pradeep was also on the board of UTI AMC. He's been the past president of Pan IIT India and Association of Indian Magazines. He has been on the board of IIT Mandi, Indian Newspaper Society, IIT Delhi Incubator, IIM Calcutta Innovation Park, etc. Pradeep is recipient of Distinguished Alumni Award of IIT Delhi and IIM Calcutta and Helen Keller Award for working in the disability sector. Pradeep is an engineer from IIT Delhi 1975 batch and MBA from IIM Calcutta 1977 batch. With that introduction, I would like to put Pradeep's presentation to all of you, ladies and gentlemen. Please give us 30 seconds. It's just coming up shortly.
Hello and good afternoon, or good morning, or good evening, depending upon the time zone that you are in, considering that this is a global event. I'm Pradeep Gupta, and it's a real pleasure for me to share the story of Electropreneur Park and the successes that we have had with you. So please allow me to share a video on the Electropreneur Park. So, I think I'll start by first talking about the performance that we have actually achieved. Electropreneur Park has been it has been the most successful incubator that has been set up ever in India, I would say. Because we were supposed to do 50 startups, we've done 50 startups, there are 51 patents that have been created, 17 trademarks that have been filed, 24 startups have got funded. 44 products have been developed, 33 prototypes have been made. And if you look at the success that has been created in terms of value creation, 310 crore is the kind of value that has been created. We have generated employment for more than 500 people, and the startups have had a success rate of 75%. And for an investment which was less than about $3 million. This is the kind of an achievement that the Electropreneur Park has had. It's an absolutely stellar performance. So let me get back into the history and just share with you how this thing came about. In 2014, we got the approval, but because this was the first time such a thing was being done by an association, a government, and a private partnership, therefore, it took long time to get the structure in place and so on. But we were then able to launch it in August of 2016. Now, of course, the project has been extended and with absolutely superb results. And a very key role has been played here by IESA, who has been the implementation partner, and supporting partner Cybermedia, of which I am the chairman. Now, what IESA did, and I think this I would like to sort of, say what differentiates Electropreneur Park, the success that I talked about from the hundreds of incubators that are there in India. It was the industry connect. Very, very strong industry connect that made this difference. What has happened because of that is that if you look at this entire list, and I like to focus on few of the bullet points here. The Esdm prototyping facility helped in terms of the design and testing of the product. There was a lot of technology mentoring which was being done by IESA members, by industry experts, and so on. And also grant from the CSR funds, that last bullet which is there. What happened was that we created a CSR fund, and a whole lot of the IESA members contributed to that CSR fund. And that created a very, very strong reason for the success of Electropreneur Park. Because for the startups, it automatically meant that they could connect with the industry. If they had their prototypes, they could get it tested. If they wanted some components, they could get them. If they wanted some testing tools, they could obtain them, and so on. So I think this has been a very, very key differentiating factor. Of course, the role that my organization played in terms of the business connect and in terms of bringing in line a whole lot of funding agencies also helped in terms of ensuring that these businesses scaled up, they got funded, and therefore succeeded as far as the startup ecosystem is concerned. I would also like to talk about the lab because there was a state-of-art lab which was created, which had a prototyping facility, power design lab, embedded design, RF design lab, and product testing lab. So it was actually possible for a startup to take their idea in from an idea stage to first making a breadboard out of that, preparing a proof of concept, and fabricating the first few pieces so that they could actually test out the market. So the lab, really speaking, ensured that there was a complete one place workshop which was available to the startups. So this was also a very unique thing about the Electropreneur Park. And let me share that with you with some of the success stories that we have had. One of them is STEMrobo Technologies. It was part of our season 1, promoting the SDEM, robotics, IoT, AI learning. In their 4th year of operation, they have done 15 crore of revenue. They have trained more than 3 lakh students. They've got an MOU with Discovery Education, amongst the top 30 startups selling on the GEM platform. So STEMrobo Technologies And by the way, they've also empowered a lot of these tinkering labs and so on. Has been a great success that has been there. Automation, Ecotech, they got 3.6 crores external investment. They got a 4 crore revenue. Essentially, IoT-based automation solution for smart buildings. Another success story, let me share with you, is that of EVI Technologies. EVI Technologies has a MOU with BSNL for 5,000 charging sites, 1.5 crore investment, 4 crore revenue. They have an MOU with Murata for setting up battery swapping stations in India. So once again, a very, very successful startup from Electropreneur Park. Univlab MedTech, affordable endoscopy tower. 3.5 crore funding they have received, 3 crore is their revenue. They are supported by Sony Corp Japan, flexible endoscopy with 4K cameras. They have filed 11 patents. Resonant Electronics, energy audit and control system. They have a revenue of 3 crores now, 4 projects, over 2.5 million square foot of building space is under various kind of energy audit and control system that is Resonant has developed. Energy saving of over 25% is now validated and proven. They have testimonials for that. Funding, they have received 97 lakh of funding by Murata Japan. Leap Aeronautics, which is a Bangalore-based startup, which was remote mentored at the Electropreneur Park. Electric vertical takeoff and landing vehicle. They have tested 1:5 prototype for full functionality. MOU has been signed with NAL for providing support on aerodynamics, structural design, and flight testing. So once again, if you look at the hello and good afternoon or good morning or good evening, depending upon the time zone that you are in, amazing that this is a global event. So much so that
Thank you, Mr. Gupta. We got a lot of insights about initiatives of Electropreneur Park, both Delhi and Bhubaneswar. And sorry, in the end, we had a small glitch there, IT glitch. So let me move to the next presentation of today. And the next presentation is on few other initiatives that ISA has taken in Bangalore together with Karnataka government. And these initiatives are called Safal and HEX. And to talk about these initiatives, we have with us Ms. Meena Nagraj. And before we bring her on to give her presentation, let me do a brief introduction about her. Srimati Meena Nagraj is an IS officer and she is currently Director, Electronics, IT, BT and Managing Director of KITS. She is spearheading the implementation of various schemes and programs of department in the sectors of information technology, biotechnology, electronics, animation and gaming and startups. She is an ex officio managing director of Karnataka Innovation and Technology Services, better known as KITS. KITS is an implementation arm of department working for the promotion of IT, ITES, and electronic system design and manufacturing, startups, biotechnology, AVGC sectors in state of Karnataka. She has earned her bachelor's degree in psychology, economics, sociology from Bangalore University and a master's degree in psychology from Mysore University. She is a strong supporter of IESA's ESDM initiatives in the state of Karnataka and has been very open and collaborative to discussions and suggestions from the industry. I would now go over to Ms. Srimati Meena Nagraj presentation about initiatives in Karnataka.
hundreds of incubators that are there.
Shall I start?
It was the industry connect. Very, very
Just
strong.
give us 30
connect
seconds, ma'am. There's some crosstalk here, and let's just fix that. Why his video is coming again and again?
Shall I start?
Yes, please go ahead.
Namaskara and a very good afternoon to one and all present here at the IESA Vision Summit. It gives me immense pleasure to be part of the 16th edition of this summit, and I wish the entire team the very best. I would like to congratulate the team from IESA for organizing the summit with the theme of highlighting India's accelerated ESDM growth and for giving me this opportunity. My thoughts on the ESDM system of our state, Karnataka. The world's fastest growing industry, electronic system design and manufacturing, continues to transform lives, businesses, and economics across the globe. The globe electronics market is estimated to be over 2 trillion. With per capita disposal income and private consumption having doubled in the past 7 years, India has emerged as one of the largest markets for electronic products in the world. Hence, building a vibrant electronics manufacturing ecosystem is central to the Make in India digital theme, Make for India, Make for the World, goal set forth by the Government of India. In order to position India as a global hub of ESDM and to push further the vision of national policy of electronics, 3 schemes have been promoted by Government of India, like the PLI scheme, the Scheme for Promotion of Manufacturing of Electronics Components and Semiconductors, which we call it as SPECS, and EMC 2.0. Karnataka is an important state for India and has been pioneer in innovation and technology. Home to the Silicon Valley of India, we are the undisputed leader in the country in sectors such as information technology enabled services, machine tools, aerospace, biotechnology, and of course, ESDM. When we talk of ESDM in Karnataka, IESA is spoken of as a key contributor to the ecosystem. It is indeed a matter of pride that Government of Karnataka and IESA have long-standing partners for several years now. Our vision is to make Karnataka the hub around which the next breed of Indian fabless startups can thrive and accentuate the existing fabless companies into the next realm of growth. Along with IESA, we are certain to propel the ESDM sector and support innovative domestic companies. In December 2018, Department of ITBT and IESA launched the Fabless Center of Excellence, the Semiconductor Fabless Accelerator Lab, which we call SAFAL in Bengaluru. SAFAL is the first of its kind initiative in the semiconductor space. It aims to help aspiring engineers and entrepreneurs to design a product. At SAFAL, access to software is provided at nominal rates. Affordability thereby becomes a major bottleneck for them. Creation is encouraged, and fabulous startup ecosystem is going to be accelerated. SAFAL has selected 20 out of 50 plus companies which have applied for these incubation and mentoring. 7 out of the 20 signed and started projects, 10 are in various stages of engagement. 20 companies are in selection stage. SAFAL has helped secure $1.6 million worth of capital for 4 of its startup companies. SAFAL and startup founders should have made use of these initiatives, and SAFAL Council recently has extended its scope to cover electronic system companies and small medium services companies who would like to invest and build electronic IP and products. Salafal, along with its ecosystem, greatly reduces the capital entry barrier for all such ventures. I thus encourage all the SDM startups who are part of today's event to explore growing with the help from Safal. The Government of India's flagship program for Idea to POC grant funding, which we call it as Elevate, a first of its kind initiative in the whole country, has disbursed funding over 114 crores to more than 488 startups till date. Out of these, one-third have been startups working in the electronics and semiconductor design manufacturing sector. We have also launched Car Semvent Fund in 2014-15 to provide funding to Karnataka's ESDM companies with a total corpus of INR 100 crores. Apart from this, there are several other initiatives we've already undertaken for growth of ESDM sector. Mysuru ESDM cluster under the EMC scheme of GOI has been established in Mysuru. The K-Tech VLSI Incubation Center at KLE College in Hubballi. The center will also provide plug-and-play tools and software such as design tools for startup to focus on IP creation. The K-Tech ESDM cluster at Deshpande Foundation in Hubli. Product-specific industrial cluster development program has been announced by Government of Karnataka with focus on ESDM for 3 districts, with Chikballapura focusing on mobile phones, Mysuru on printed circuit boards, and Chitradurga on LED lights. As stated in our ESDM policy, which is invoked till 2022, we aim to stimulate the growth of 2,000 ESDM startups during the policy period. Our policy has also identified industrial automation and automotive electronics as part of our focus sector. With the advent of technology such as AI and machine learning, industrial automation and robotics is taking off in this world. There are multiple companies exploring and researching and converting their ideas to concepts. Also, with the IoT ecosystem exploding, many of its users will be geared towards automation of machines, industrial tools, and use of robotics to improve productivity and quality. Local companies working on such products will be promoted by the government to boost exports in this sector. In conclusion, I want to say that growing ecosystem and the statistics I have spoken have been not only highlighted the ESDM sector in India and Karnataka, but have shown the impact the sector has on the overall development of the country. We look forward to seeking support from all the stakeholders to further the ESDM in our country and help us reach new global heights. Thank you, and I once again thank IESA for providing me this opportunity. Thank you.
Thank you, Srimati Meena Nagraj. A quick word of thanks for all the 3 speakers of the previous EP Bhubaneswar, Mr. Manas Panda, EP New Delhi, Mr. Pradeep Gupta, and for Safal and Hex, Ms. Meena Nagraj. Thank you very much for coming here and giving us information about these initiatives of IESA with respective governments. I now move to the next session, but before that, I had a small announcement to make. So we have, ISAvisionsummit.com is the link for all the audience folks to register and join there. But there are certain WebEx links that we are sending out to our speakers. And besides speakers, we are seeing many other folks receiving and joining that link as the speaker. So we request you to leave that link and come to ISAvisionsummit.com to join as an audience. So kindly, only those who are speakers should join the WebEx link being sent out. Now, we are moving to 3 important keynotes by leaders of semiconductor industry and our members in India. We would first start with a keynote by Mr. Santhosh Kumar, who is the country head President and Managing Director for TI or Texas Instruments in India. Before we put on the presentation by Mr. Santhosh Kumar, I'm pleased to give a brief introduction of Santhosh Kumar. Santhosh is President and Managing Director of Texas Instruments India, a position he has held since 2013. Prior to this, Santhosh was business manager responsible for growing TI's embedded business in ADAS, which is Autonomous Driver Assistance System, and video based out of Dallas in the US. Under Santhosh guidance, TI India has grown into a large R&D center for the company, driving cutting-edge innovation in analog, embedded, and overall systems. Today, TI India does end-to-end product design and development spanning industrial, automotive, medical, personal electronics, among others. While the team in India has grown significantly to include many highly qualified and trained design engineers, Santosh's focus is on driving innovative, value-added work for customers with clear business impact. A technologist at heart, he strongly believes that best innovations are those that prove themselves in the market, adding value to customer and revenue for TI. It is this philosophy that has contributed to TI India's success, manifested in the fact that some of the most innovative and industry-defining products in the company's portfolio in industrial, radar, and automotive have been designed and developed by India team. Santosh started his career as a design engineer at TI and was also part of Technical Ladder at TI, a select group of technically advanced engineers in the company. He shifted course in 2007 to take on key managerial assignment, and in short span he moved to lead the TI India. Santosh joined TI in 1995 and has more than 20 years of experience in semiconductor research industry. Prior to this, he worked with ISRO. Santosh is a system and software engineer from BITS Pilani. Ladies and gentlemen, join me in welcoming Santhosh Kumar for his keynote address. Over to you, Santosh.
Okay, let's begin. I hope you all are having a wonderful time, enjoying the Vision Summit. I do hope all of you, your families and colleagues have stayed safe during the pandemic times. 2018 was a very important year for semiconductor industry. We crossed shipping 1 trillion units. We crossed that number again in 2020, and this year projection is between 1.1 and 1.2 trillion units.
Okay.
We are also at $450 billion. Let's look at what drove the growth in the last 20 or 30 years, as it will help us project the future. In the 60s, it was the mainframe computers that drove the growth of semiconductors. 70s was the era of mini computers. 80s and 90s was the era of personal computers. Then it was a world of embedded computing. Came the growth of various communication systems to bring data to these devices from the net. Cell phones in 90s and early 2000s drove growth, as we all know. We created new electronic boxes and created new ways to create and consume data. So essentially, it was the new use cases of that time that fueled the growth of that era. So we have to have a good estimate of the new use models of the coming era to predict the future. In 2020, we have sold 275 million personal computers, 1.3 billion cell phones. We change computers at the rate of let's say 4 to 5 years, and cell phones maybe 2 to 3. All put together, the number of electronic systems we ship in the world today, maybe 2 billion boxes, stretch it to 2.5. And several of these take multiple years to buy again. And we have 7.5 billion people in the planet. So you get the point on the volume growth that can happen in a natural way. Still, there is a lot of excitement in the semiconductor and electronic segments all around the world. So let's look at what is creating that excitement and driving that growth. You can see on the upper right-hand corner chart where there is rate of growth we have witnessed: auto, industrial, communications, consumer, government or military, computers, in that order of growth for the last 5 years. Highest for auto at 5% to around 1.5% CAGR for computers and tablets. Then we see a trend of AI and autonomous everywhere. All systems getting more autonomous. It is ubiquitous, whether it is your car, your home, your work environment, or appliances. The products are building capabilities to sense everything, know everything, and handle every situation seamlessly without interventions. EV and HEV, big data, HMI and augmented reality, industrial IoT, safety, security, the list goes on. These trends are changing the landscape of electronics and semiconductors in ways we have not seen earlier. Just look at communication technologies and faster adoption of newer technologies around the world, 5G and beyond, and volume of data to be created, processed, and consumed to solve problems that we could not solve earlier. Let us drive further to look at what is going to be the new future. Electric vehicle charging stations are becoming prevalent. Increasing adoption of EV is making the presence of charging stations more around the world. Take a look at home control systems for air conditioners or lighting, or even look at personal healthcare systems. Not alone are these systems completely semiconductor driven, but their previous generation products have little or no electronics content. Think thermistor, think fuel pump in gas stations. While these are new products that are starting to consume semiconductors, some in newer ways, they also pose an interesting challenge. These products are driven by a large number of small to medium-sized companies. They have very good engineering teams driving those products, but semiconductor electronics is a new domain for them and will have 1 or 2 senior engineers. That's the team, all of it, driving specifications or implementations of these solutions. As the nature of our customers change, we are adding a new dimension to electronics to make systems that are extremely easy to use or easy to consume. Easy to consume does not mean that products have less complexity or are easy to create. They're just easy to put to use. Mostly, maybe more challenging and innovative to create. These are some of the examples of mechanical systems moving to electrical systems and electrical systems moving to electronic or intelligent systems. On the right side, you also see completely new class of products like drones or even robots as companion aids for elderly who need help. Just imagine a couple of decades back, the factory visits we have made and look at how factories look very different now. In several TI fabs, it's hard to see people on the factory floors where there are several robots moving around between various stations. Just look at the power of sensors spread on factories, doing predictive maintenance, reducing machine downtime, and avoiding loss of several productive hours. Several of these are new class of products that did not exist a decade back. They are serving applications that are new to users. Think about ways in which factories will change when robots work alongside humans. Think about safety considerations of those systems, additional efficiencies it brings, but intelligence it needs to provide. Think of sensors, signal chains we have to process in each of them, quantum of data to be processed in real time. Let's take cars as electronic systems. Cars have changed and are undergoing further changes. From just under an average of $10 to $20 electronics that existed in cars a couple of decades back, now to having hundreds of dollars per average car. Not considering EV yet, automotive industry is accelerating adoption of electronics far more than ever, and there is tremendous future opportunity. We see higher electronics everywhere in cars, be it in body electronics and lighting, powertrain systems, infotainment and cluster, or driver assist systems. In the Indian context, take a look at revolution happening in the two-wheeler markets. We are market leaders of two-wheelers in the world, where electronics almost did not exist much, to significantly higher electronics coming in two-stroke engines, driving efficiencies up, increasing safety, or usages like better lighting, mobile charging, going all the way to evolving trend of efficient electric bikes. The summary of this slide is two. One, there is growing number of new opportunities that are coming into semiconductor way for us to innovate and serve. And two, the semiconductor content of existing solutions is increasing dramatically to solve more problems on the existing products, like in cars. If we are new engineers entering the work life, or new companies getting into products, or existing companies innovating and expanding, or simply engineers who have spent a couple of decades in the industry, it doesn't matter. There is no better time to be in the semiconductor industry than now. Let's take a deeper dive on the data. Here, we are comparing population growth over last 30 years, CAGR of gross world product and semiconductor growth. Clearly, semiconductor growth is outpacing other two in a big way. You can see from 2015 to now, we have crossed 1 trillion units. We have just added another 30 chips for every person in the world every year. There are two ways we have looked at innovation. One is technology driven. For example, when TI is working on single chip millimeter wave solution, transmission and reception of 77 gigahertz in CMOS chip a decade back, we knew it was an important milestone to be achieved, but we had no realization on where all it can go. From automotive solution as radars to find distance to cars, or to curb, or to assist in the auto park, to finding the health conditions of the driver, to protecting the door of the car from not hitting the next one in a parking lot. The applications keep expanding. It also finds applications in adjacent markets like industrial. People counting, finding oil levels in tanks. All these applications leverage the technology innovation and created novel ways to solve new problems. But what drove the change was technology innovation in this example. Let's look at the examples on the right side. Let's take augmented reality. Augmented reality or newer ways to experience a content or HMI drove several technology innovations on the left. GPU, processor performance, display technologies, lower power, immersive audio, Clearly, examples on the right-hand side are pushing the boundaries of technologies. Look at ADAS systems in a car, driving GPUs, sensor technologies, sensor fusion, distributed computing. So while we see new markets for semiconductors, we cannot easily determine which is the cause and which is the effect. It might not matter so much, but the combination of an appropriate technology solving a relevant problem is key. For semiconductor to expand, you can see a multitude of evolving technologies and compelling applications coming up here. Let's take a deeper look at how innovation is coming up further. We can see that battery energy density is doubling in 36 months. Figure of merit of ADCs, for example, is doubling in 36 months maybe. CMOS scaling on an average takes greater than 18 months, whereas mobile traffic is doubling in 16 months. So the demand coming from applications for technologies is growing faster than technology innovations is catching up. So there is absolute need for innovation in circuits and systems to cater to the growing needs of applications to augment technology innovations. Let's look at some time to see what are the opportunities for innovation in the continuous world, analog world, real world analog signals. Take, for example, medical market, say ultrasounds. There is a lot more information ultrasound scans can provide now for the doctors compared to what they could do a few years back because of advanced analog technologies and circuits and the level of integration and signal chain processing. We are providing an ultrasound, transmit and receive paths. Look at this from the perspective of early diagnostics of impending problems or using less invasive or more affordable scans, giving higher precision data. While requirements on precision, bandwidth, power density, cost, integration are continuously increasing, we're able to provide both incremental and creative improvements to solve process variations, temperature drift, aging issues, or package stress. Adaptive and intelligent solutions of analog world are very interesting. It looks at energy optimizations, latency changes, and creates intelligent solutions covering self-calibrating circuits, digitally compensating for analog circuits, or moves effortlessly between time and frequency domains, or simply by providing high precision, stable references. We will sometimes provide accurate clocks and circuits, or simply have sometimes inexpensive clock sources and compensate for the inaccuracies of shifts over time or temperature. The complexities to solve analog world issues are even more challenging. Just inside TI, we have more than a dozen process technologies that we use to provide analog signal processing. Let's compare the last 30 years and coming 30 years. While we were operating on commodity CMOS as the dominant technology, we have need and opportunity with differentiated technology to supplement commodity CMOS. When we were dominated by catalog products, we are seeing optimized application-specific architectures emerge. While the next big thing dominated the market in the past. Example, PCs, cell phones in the last 30 years. The future is definitely giving an opportunity for us to make everything that exists to make it smarter, be it medical, communications, automotive, home, or industrial. Future definitely looks challenging and interesting with large number of products in different applications using differentiated technologies. So to conclude, How do we create our niche? Clearly, there are more problems coming to our space looking for solutions. It's also true that there are less number of billion unit opportunities. The future opportunities are systems leading. Understanding opportunity comes from truly understanding the problem space. There can be one solution to many problems, even though they might have multiple dimensions to the solution. Competency on multiple dimensions will help us decide whether it is optimal to solve a problem and where is it the most optimal place. Sometimes a noise issue is solved in analog. Sometimes it's ignored there, carried forward, and eliminated in the digital domain or filtered out using software. Ability to collaborate with diverse competencies will be relevant for people, teams, or organizations. Opportunities are many, as we saw, and yet to see, and time to act is now. Thank you for your time.
Thank you, Mr. Santhosh Kumar, for that perspective on evolving semiconductor industry landscape and the technologies. In interest of time, I've shortlisted a number of questions that have come up from the audience, just down to 2 questions for you. First question, Santosh, is around challenges that semiconductor industry is facing on the availability of talent or skills. So the question says that in general, a lot of youngsters are taking up more software and IT kind of field rather than semiconductor design or electronics. What is your perspective on skill development for ESDM or semiconductor space in India?
I think it's not an either or question. We do need a lot of people working in software because that's an important domain that's growing for both the world as well as for the India, right? And we do need people who are very interested in electronics, engineering, core skills to be available for semiconductors and electronics ESDM. We had to have a holistic approach in making sure that the right levels of experience are available in colleges, and we should support it. Industry has to play a very active role in making sure that the syllabus that they are actually studying, the projects work that they are actually studying are important. TI wants to hire larger and larger number of people from the campuses because we do believe that's the way for us to get very good people, as well as that's a way for us to connect with fresh thinking coming from the campuses, etc. So we have a strategy to do that. And we do believe that more and more companies are actually coming in that direction, right? And I think there is enough and great people that we have. We need to go back and connect with the best colleges and continue bringing fresh talent there.
Thank you, Santosh. The other question from audience came around what are the focus area for TI India for product development?
It's an interesting question. We have 70 to 80% of TI's product lines, which will be like smaller companies in TI, have a presence in India, and more than 70% of them have only presence in India, which means that if TI is releasing a product anywhere in the world, those things really happen over there, and it spans across entire spectrum of TI's products. Right, TI has 100,000 active products that we have. And we do release definitely a large number of products. For those products come from India. It includes digital, analog, power signal chain, EDA software, DLP software, entire microcontroller product lines, processor product lines. I think the list keeps going on, right? And I think for anyone who's got interest in technology, in semiconductors and electronics, we absolutely do have a place, right? And I think that is pretty much applicable for a lot of other companies, not just for TI. I just wanted to know that it's important for us to have the right interest that we pick up after college, and there is enough scope for all the people here. Thank you, Vivek, and congratulations for a wonderful summit.
Yeah, thank you, Santosh. And of course, TI was the first global semiconductor company to come up and set up shop in India, and hopefully it will continue to do well and hire a lot more folks in from the semiconductor side. Thank you for your time, Santhosh, and very good talk.
Yeah.
Appreciate it.
Yeah, definitely.
Thank
We were
you.
the first, but we wanted to be the most relevant. That's more important for us than being the
Absolutely.
first.
Absolutely. Thank you, Santosh. So, ladies and gentlemen, audience, we'll move on to the next keynote speaker for today. Next keynote speaker we have is Mr. Vivek Sharma, uh, who's well-known figure in semiconductor industry in India. He's been the pioneer and also part of the ISA since its inception. So before Vivek makes his presentation, let me do a brief introduction. Although Vivek, you're well known, but it's my honor to introduce you to audience today. Vivek Sharma is Managing Director of ST Microelectronics India, and he has held this position since May 2016. Vivek is responsible for company's overall operations in India and driving ST strategic initiatives in the country. He is also Group HR Head for ST Asia Pacific Region Sales and Marketing Organization since 2017. Vivek began his career with SGS Thompson, which is now ST Microelectronics, in 1991 as a design engineer. After working for a few years at ST in France, he returned to India and went on to gain more senior responsibilities in positions spanning R&D, administration, sales, marketing, and strategic leadership roles. In addition to his responsibilities at ST, Vivek has frequently served as an elected member of Executive Council of IESA, as I already said, as well as with European Business Group, Indo-Italian Chamber of Commerce, and industry committees. He is recognized for his role in shaping the semiconductor sector in India and his contributions to various forums in India and global. Vivek also holds 3 international patents in integrated circuit design. Vivek Sharma is currently based at Greater Noida in India, and he received his Master of Technology degree from IIT Delhi and a Bachelor of Engineering in Electronics and Communication for Punjab Engineering College, Chandigarh. Now I'll pass on the baton to Vivek for his presentation, and after that we will put it on for a live Q&A. Vivek, I'm sorry to intervene, but we cannot hear you. Just give us few seconds to see where is the glitch in the audio side. We can see the slides, we can see you, but we can't hear you. Vivek, can you hear me when I'm speaking from here? Can you hear me?
Hello,
No, it's
hello, Vivek. Do you hear me?
yes, I can hear you now. I think we are good to go.
Okay, thank you very much,
Let's
Vivek.
get started.
So I will not repeat everything, but I
Yeah.
will repeat at least one thing that thank you for your very nice introduction. Not really, sure that whether it is our same names, which is more than what they deserve. But thank you so much, Vivek. It's always, a pleasure to be together on this platform, sharing together and brainstorming together. Presentation is coming or not? The presentation is coming there now? Sorry, colleagues,
It's coming.
just to be
Vivek, we
sure
can
that
see your
everything is okay.
slides and we can hear you. Please continue.
Okay, okay, perfect. So now let's, these are all things we are all learning. So once again, thanks to all of you to be present in this session. And I believe that this is just before the lunch time. And thanks, Santhosh, for giving, let's say, a very good view of the industry. And in being, very similar, I will share with you a few points which are, of course, similar, but perhaps still make sense to make some repetition. So first of all, semiconductors is getting stronger and stronger. You remember, as Vivek was mentioning, we are in this field since a long time. There was a period when this was considered as a sunshine industry, gung ho, always double digit. But then there was also a time when we started to see that maybe, it is coming down. People used to analyze taking decade-wise growth rates of the industry, and it was showing that it is coming down. And yes, of course, any industry which matures at one point of time, it cannot keep on growing, forever in double digit or very high double digits. But in the last few years, there is once again a kind of change. We'll not call disruption because this was there already, but we definitively see very strong momentum once again. So if you look at this chart, and we can see that in these 3 years, the growth rate is quite unprecedented, right? So about 440 billion, forecasted to be crossing 600 billion world over. Actually, this year we will be the peak after there was another one in 2018, if you remember. But the difference was that it will increase and there would be this cyclic industry. We know semiconductors, it will go up, come down. But nevertheless, the momentum here is really very, very strong as we can see it. As was already mentioned, I will just highlight that we know if we look inside semiconductor industry, two things have really helped us all the way. Moore's law, more than more, and so on. So this is one which means more complexity, in less area, cost effectiveness, portability, all those things inside. But outside, definitively we see penetration is increasing. We see the semiconductor per electronic device is increasing. And then it is going those places which no one thought that even semiconductors or electronics can go. So all this put together is making it extremely exciting for almost all the stakeholders involved in this industry, including ourselves who are present since long there. So what I will do in today's session, we will take some of the long-term strategic enablers for electronics, looking from semiconductors point of view. And we pick three also because very relevant from ST point of view, and hence we will be able to go a little bit in detail. Once again, these trends are well known, but we'll take the opportunity to explore them a little bit more in detail. So first one, as we know, smart mobility, and this is really to make driving safer, greener, and more connected. I will take one by one as we go further. Second one is power and energy. The one thing we see that as this sustainability is the point, what we are doing is that, okay, push everything to power and energy. If we are burning the fuel and it is creating trouble, let's put it to clean energy, which is power and energy. So it is becoming like a mother there. It means that it needs to cope up with all these demands which are coming over there and how to really remain sustainable as well. And finally, as we see here, the third trend we will take up today is the way IoTs are becoming pervasive, all around connected, as you can see. And then there is a smartness there, but also more important is also the infrastructure, which has to be present on which all these IoTs or devices can be communicating, can be achieving something meaningful. Let's take one by one. So here I will, Santhosh was giving a nice cause and effect. I will just change it. I will say that let's see it from demand and supply side as well. So absolutely, there are demands which are there, which supply side has to come up to be able to solve those demands. But then there is innovation also on supply side, which on the other side, demand develops to take care of that. So looking at smart mobility, first of all, safety, I think we know intuitively, but if we put the numbers, they are staggering. As per WHO, 1.3 million people lost their lives in a single year, which is a lot. And 20 to 50 million people get injuries. And then, of course, we can put the cost around it, which is whopping, is quite high. So in that sense, the safety at the road, not only for the passengers, but also other road users, remains extremely important aspect when we come to mobility. And this would stay so and should stay so also, because there is a big implication there. Then not only the safety, but we need to make the driver comfortable, convenient, more empowered, because drivers still today play an important role in all this kind of safety on the road. The second one, as you can see here, that definitively there is, we know very well, as I mentioned, that we put all this kind of combustions on the electricity. So electric vehicles are supposed to grow from 9% today, from 2019 to 20% in 2025. Nevertheless, we need to be careful that in these 5 years, from 2020 to 2025, still 90% of the new vehicles which would be produced would be based on internal combustion engines. So it's not something that we can purge because it has a big impact, and therefore the focus has to remain there when we are thinking of smart mobility till the EVs are really becoming very big. But on the other side, this remains a very important aspect still to keep into consideration. Now, if we have to imagine to meet this kind of demand, as I showed on the previous chart, let's think. So what kind of vehicle we need? Again, is very intuitive, but just to put it on the paper and to say, if I could build a vehicle which is safer, which is more friendly for the environment, more connected. Connected, there are many service providers, but also my own applications. And, I will connect it also with the more convenient one if it can upgrade the software like we are able to do on mobile phones, but without disruption. We cannot put it off. Yes, in some cases we can, but in some cases perhaps not. And then if I can find a parking lot, I can find the most optimized route, etc. So if it becomes, or as a driver, if I can be pre-advanced that there are some problems there. So this is a kind of conducive circle. One element gets connected to the another one, and it helps the other elements also. Finally, whenever it is personal vehicles and all, they need to be affordable. So even if those dimensions on the top are a little bit pulling it on the other side, but we need to keep a watch that these vehicles and smart mobility remains very affordable. So let's now take a little bit deeper dive. There are two elements which are happening there. One is car digitalization, and second is the car electrification, right? These are, if we have to broadly classify that what is going on there, so we can classify in these two big categories. Electrification, I will take along with power and energy, but let's a little bit focus on car digitalization. So first, starting is assistant driving. We know that there are SAE level 0 to level 5, different levels, but assistant driving is something which now is actually also getting mandated by the regulations, because that's where there is direct safety, and so these regulations drive, and in a way this is making it mandatory for the vehicles to have those kind of compliances there. Second one, if we move up in the level and become ambitious, so if we can remove the elements of variabilities, and if it can, it is a tall claim, for autonomous vehicles everywhere for everyone is going to be a journey. And even if today we are not very clear that how it would look like, but there are definitive or green shoots, robo taxis, robo tracks, they are making their way. So it's clear that this is the direction the industry is going to be, and we as users can look forward that at some point of time, depends upon the country also, we will be able to take advantage of this kind of development. Then these last two are with the soft aspect, software reconfigurability of the vehicles, right? Like I mentioned already, how to have a remote seamless software update, right? So it means we need to relook into the architecture of the cars as well, the way systems are designed there, so that these things become seamless and they can be done, without compromising any safety issues. And last but very important, with car, all the data, everything being there, going up to the cloud, it brings lots of opportunity for various players to be able to provide services, to get connected to the applications, to companies, to OEMs, the automakers, but also to the insurance companies and others. So is really a very important aspect, which will, as we will see, that it will become stronger and stronger. So all this is boosting the semiconductor content per vehicle, and I will show. Let's just spend a little time that about the architecture and the evolution of this architecture inside car. So if we look here, then we can see that there is embedded processing, microcontrollers, MPUs, and application-specific processors, which are able to do multiple things. But the demand side, what we saw before, if we need to migrate there, we need to move into a system where there is much more integration and also more single points. If we can achieve one, great, but at least consolidated points which are able to manage. So it's a kind of mini revolution happening inside the car, so that we can put it together, they can be integrated, they can communicate with each other in much better way. And as you can read here, much higher performance, 10x is in our view, is the computation power needed, real-time capability, and high speed in vehicle communication. We discussed the last 2 points already. So in that sense is a kind of big movement in terms of redefining the architecture within the car. So all this, if we put together, is really boosting the semiconductor content. Is a little bit involved chart, but we can see that here from 36.36 billion in 2019, it is supposed to go to 45. But some elements like ADAS, which is, as we said, the digitalization part, which is also connected with that, is moving pretty fast. Similarly, the electrification and the content of semiconductors depending upon the car, like you see internal combustion engine, hybrid, and also fully electric vehicle, the content of semiconductors is boosting. And when we see that the direction is in this direction and semiconductor content is going to be going up, it indeed becomes very exciting. Let me come to the second one. So this was all with the smart mobility. Then let's have a focus on power and energy. As we noted that, one way to make the things cleaner is to put it on the electricity, but then let's see what kind of demand challenges it is creating. So first of all, 30% global electricity demand will increase from 2020 to 2030, which is a lot, 30% in 1 decade. On the other side, we must decrease the carbon dioxide emissions. So if we have to stay in 1.5%, 1.5 degree centigrade warming up to that level, then we need to reduce 45% from 2010 to 2030, right? You see, equations are already forming. Then we can utilize, and this is the kind of target, that 10% of renewable resources should be doubled from 2020 to 2030. So energy efficiency and renewable energy, that is where the whole game and catches. Again, let's imagine a little bit how to meet up with this demand. If my power systems could have higher efficiency, higher performance, better form factor, lower system cost, and faster to market. I will go a bit fast so that we directly come that how we can do that. So how we can reduce or improve the efficiency and reduce the power losses. One point is that, there are 2 ways and combination, 3 ways. So one is just focus on the individual components and let's make them very efficient, clear. Second is let's focus on the system and let's optimize it. Third, to focus on both. And I think it is a very simple answer that we need to look at the overall power system and to optimize at the whole system level. And then, of course, at the individual level, whatever we can optimize, we should. But sometimes there can be a conflict. If we need to achieve higher level of optimization at system, we may need to sacrifice at individual level some, because it just to enhance the availability of that. Higher performance, then find a way how we can manage larger power, right? And we will come to that. Form factors, because is cost of ownership, there is space and everything related with that. So if we can manage higher energy densities, this will be able to help quite a lot in reducing the form factors. And lower system cost and cost of ownership, I think, is very simple. We'll just say that integration levels have to increase also. Finally, faster time to market, particularly when we are pushing everything to power and energy, we need to be developing systems fast, have pre-integrated solutions, and optimize the components so that we can develop these solutions in a faster way. So silicon carbide, we all know, we have heard this name, but just to reflect upon it, there is a kind of magic here. See, I was a designer for phase lock loops, so use the band gap reference. So it's quite personal over there as well. Nothing personal as far as the energy band is concerned, but a bit of association. So as we know, in the conductors, the conduction and valence band. So there is a valence band and electrons needs to be present here to be able to conduct. Then we have on one side of it, which are conductors where they are almost overlapping. Then on the other side, they are completely away from here and makes the insulator. That's where we have been. Silicon carbide is providing us 3 times the energy needed for this to jump from here to here. Now, this is a technical topic, but I will straightway go to what are the implications of this. Smaller size, lower energy losses, higher voltages to manage, higher frequencies it can handle, and then also the temperature tolerance is higher as compared to that one. Now, everything looks so nice and green that why did not we do it? As is true for any technology, there is maturization of technology. We should be able to manufacture it cost effectively, sustainability point of view also that it is sustainable as we go through. But the great news is that now this technology is available and is helping a lot in both the segments of automotive. So that's where electrification, as we said, and also for industrial. What are the impacts of this kind of technology? As we can see that bringing that in, because it reduces the losses and so on, the cars can go up to 600 kilometers. And no one would take a car which has to be charged every 20 kilometers or 50 kilometers. Similarly, the charging stations, 350 kilowatt, for example, they can manage 2x energy, so it gives us faster. So it's the convenience point. If we can charge the cars faster, and it also helps in reducing the weight. And lower the weight we have to carry, more efficient the overall thing would be. So sometimes it's surprising that such kind of technology, how it can transform that particular application in a big way. Similarly, if we draw a parallel and coming to power and energy system, by utilizing this, we will reduce the power losses by 50%, speed up 5 times the frequency, total cost of ownership, components, operation, maintenance included, is reduced by 20%. And then as per, and this reduction of 20%, as you can see, is coming from the study which is done. And size per weight moves up by 80%, right? So with an average reduction of 50. So it means that overall we have smaller, more compact machines, right, which we can pack in much lower dimensions and affects the overall system. Last one, Internet of Things and 5G. So we know smart, once again to remember, that is the things which can sense, think, act. So fundamentally should be sensors, should be processors, should be able to connect and take actions if needed. And then 2 elements which are important is the power and also the last one, the security, because with so many, as you can see, is the picture is showing that so many connected, we would not like to compromise on the security aspect of it. So if we see, and this is the demand, 2 billion industrial IoT and utility connected devices would be there by 2022. Then IoT security service market will be, I am using the word, perhaps is already now $10 billion in 2021. And we see that there would be 90 million new 5G based IoT connections in 2026. So if once again we put it all together and we imagine with the same way, if only my connected device had more computed power and memory, lower power consumption, a multiplicity of sensors depending upon the applications for data collection, easy connectivity, and more security and faster time to market. I go straightway here, how we can achieve it. And that is the kind of demand coming on semiconductors to be able to bring more MIPS and flops, right? So it's simply the processing speeds, bring AI accelerators, graphics for memory, bring more, non-volatile memories, more flash inside so that it can manage more memory and much more kind of processing speeds. Low power operating modules, efficient computing, and as I highlighted before, to focus on system, not only at the device level. For sensors, it should be able to bring all kind of sensors together, whatever are needed by the applications. And with each passing day, we are having new plethora of sensors more and more. Finally, the challenge here, which is a little bit different from the previous two ones, is that so many devices need to be connected easily. And for the developers, it should be easy way to be able to develop the system faster and in easier time to market kind of situation. So the whole infrastructure is needed. It is hardware, software, protocols, possibility to prototype fast, and possibility to also go to production in a faster way. All right, so these were some of the trends repeating: smart mobility, power and energy, and then IoT and 5G, which we see as ST microelectronics and which are directly relevant to us. So I will take just a couple of minutes to share with you about ST. So last year we did $10 billion and we are 46,000 employees and 88,000 employees in R&D. We are in India, we are present 870 engineers out of them, right? So we are IDM. As you can see, we do have manufacturing sites also and strong commitment to sustainability. Then we are addressing four markets in automotive, industrial, personal electronics, and communication equipment, computers and peripherals. As you see, I'm going faster already. We have discussed, so you can connect our strategy with it. And I will just spend one moment on sustainability because, for companies who are helping to, not, I will not use the word to solve sustainability problem, but at least to help manage it, they need to develop all those things by themselves also being sustainable. Otherwise, it would not work. We may develop something highly sustainable, but if we are not ourselves, really focused and really committed to it, it would not work. So you can see that for ST, it is an integral part of our value proposition for our shareholders, for customers, and also for all stakeholders. I will go fast to this one. I think this is an important slide. So it means that when we are creating technology for a sustainable world, for example, by bringing in R&D, innovation, and also we have a unique program calling responsible products, which is an interesting word because whatever we produce, we need to be conscious that what impact it will have on the environment and society at large. Then, of course, we need to take care of people. That is really our core ingredient of that. Take care of the planet, right? It could be just managing the wastages, but also bringing in renewability. And I will share with you what are our targets and create long-term sustainable value, right? Whatever, as I mentioned, there was a question before. We need to promote science, technology, engineering, and mathematics. That is the only way to be sustainable for this kind of industry and also our other stakeholders overall. So as ST, we have taken this milestone that by 2027, we'll be carbon neutral. And this is in compliance with the 1.5 degrees centigrade scenario. 100% energy would be picked up from renewable sources, as you can see also in the curve below. And we will not only work, ourselves, but with our partners also upstream and downstream. Last two charts. ST in India, we are present also coming from middle of 1980s, 1987, as you see. And today we are present at four places with quite good number of patents and also doing, design and development of SOCs, IPs, reference designs, applications, and so on. And then just multiple awards is really a pride. and for us to be able to achieve all this. To conclude, innovation in semiconductors is essential for enabling key industry trends. ST's approach is long-term investment, like you saw also in silicon carbide, in the fundamental technologies needed to support the trends, targeting specific markets and applications that benefit from our technologies and drive the innovation, developing products and solutions that meet the needs of our customers, and finally, creating innovative and sustainable technologies to feed all this. Thank you very much. Once again, it has been a pleasure to be together. I hope I am in time, Vivek.
No, it's a very good presentation, Vivek. I must appreciate. Very good coverage of evolution of semiconductor industry crossing $500 billion mark this year, which is a landmark for our industry. Then you covered very well how the content of semiconductor in the automobile is growing rapidly, and then 5G, power electronics. You touched all the right topics that are relevant for us. So a couple of questions here from audience for you. In interest of time, I'll just pick maybe one or two. Uh, First question comes to you again, which is being addressed by previous speaker also around the challenge around skill and talent availability for our industry. You understand this question. You're also sitting as a HR head, on the HR Council of ST Asia. So would you like to comment on, how do we address together the scarcity of talent for our industry in India?
Yes, sure. Thank you, Vivek. So here already, I think Santhosh commented. I will go a little bit beyond. I will say that finally, these students are free to make a career choice. Good news for them, as the new generations come, there are plenty of choices, right? Which perhaps in the beginning they were restricted. And as we see, as the industry is growing, we are injecting capex overall industry in the range of $8-9 billion every month. So it means we will need people. And therefore, it is very important that semiconductors, once again, I use the word, is put in the right shape and form in the minds of our young generation, younger colleagues. So what we will need to do? We need to reactivate, and Santhosh was mentioning, I would repeat, start going back to campuses. See, many times what we can do that there is an experienced engineer, take him and all, but take him and her. But that is one angle. But as an industry, we will not solve. So we need to go for skill development. The best way is to join hands together. We have platforms like IESA rather than doing our individual efforts, but put together and then have a much stronger presence in campuses, I would say. Bring the students, tell them there is a great future ahead. They can do all the innovations and also they can build a really fruitful, valuable careers. So that's what I would recommend. And this is what we will do. We have been there doing there, bringing all the trainees from institutes and so on, but we will need to further push it. But I repeat once again, ecosystem coming together, and IESA is a great platform that would help a lot rather than just individual efforts. Thank you, Vivek.
Sure. Thank you, Vivek. So another question here is around supply chain.
Yes.
Whatever you can address, I would still put the question to you. So I think a lot of manufacturing companies are faced by supply challenges, semiconductors. So the question is asking what specifically ST is doing to expand its, manufacturing or investment in manufacturing to expand capacities in coming years. Whatever you can throw light at.
Yes, so I think that this is quite common to all semiconductor companies who are in the manufacturing domain. And like ST, we being an IDM, we are present there, and we are also enhancing our manufacturing capabilities and investing. See, for any IDM, there is always capex need to be injected. Then, depending upon the demand, we need to increase it, and therefore, as ST, we have also enhanced it. And we believe, as all industry together, that, sooner or later this problem is going to go away. Now, what is difficult to say that by when? But on the other side, what we can say is that yes, the whole industry is investing. They are putting much more capex there. So the demand of the world, unless we have another one big element which would consume semiconductors, which is always is a pleasure, but although it creates a problem for the overall supply chain. But to answer, yes, as ST, we are also investing in capex, as we have been doing in an enhanced way, so that we can manage this situation in a better way.
Thank you, Vivek. That's closing on a positive note. And yesterday, for the audience, if they've missed this news, yesterday evening, yesterday we had a keynote from Sanjay Mehrotra, CEO of Micron. And late evening, I saw an announcement from Micron investing $150 billion over next decade in expanding capacity and R&D. So overall, I think semiconductor industry is doing great investments, and hopefully in a period of time in the midterm, we should see better supply chain. Thank you very much, Vivek, again for your time and coming live on Q&A as well as your presentation. Thanks a lot.
Thank you, Vivek, and thank you to all of you. Have a nice lunch. I hope it's a lunch break now, Vivek, right?
We have a last keynote from
Okay.
Anku Jain,
Sorry.
your fellow
No,
colleague from
my friend
Delhi.
Anku Jain.
Yeah.
Yes, please
So,
stay to also take the perspectives from Anku. All the best, Anku.
yeah.
Thank you. Bye bye.
Thank you. Bye, Vivek.